Hello everyone, welcome back again to the course Comprehensive Slope Stability Analysis using PLAXIS 2D. This is tutorial number 19, Influence of Benching on Slope Stability using PLAXIS 2D. So in this lecture, we will explain what is the effect of benching on slope stability. So this benching is one of the solutions to increase the safety factor of a steep or high slope. And maybe sometimes in practice we have a high slope. For example, as you can see in this example, the height of the slope is 20 meters and the slope is 1:1. And in this case, if we analyze, maybe the factor of safety is low or maybe less than 1 or maybe near 1, and maybe it's not acceptable according to most of the guidelines. So benching is one of the solution. Maybe we have another solution. We will talk about all different types of solution and improvement of slopes to increase the safety factor. So in this example we will talk about the benching and how benching increase the safety factor of the slope. So we have this geometry first. We have a soil which is a 5C soil. It has a cohesion and internal friction angle, and as you can see, this is a geometry which we are going to use in this example. And first we will use this slope which has no any bench, and we will see the factor of safety and failure surface of the slope. And after that we will change this slope like this one, and we will use 3 benches, and after that we will run the analysis again, and we will see the difference between the factor of safety. So I will copy the title of this lesson, and we will start PLAXIS 2D software, and we start a new project, and I paste the title in here, and we click OK. And as you can see, this is our geometry. So we will draw using a soil polygon in here. That's why I proceed to structure, and we click on create a soil polygon. So we will start from this point, and we assume this point is a 0, 0 coordinate, and I will start from here to 70 meters in X direction. So I start from here 0, 0 and 70 by 0, this point, and after that we have 35. So this coordinate will be 70 in X direction and 35 in Y direction. And in here we have 25 meter. So this point at crest of the slope will be 45, because 70 minus 25 equal 45 meter. So this one is 45 by 35 at Y direction. And also we have this point which is 25 in X direction and 15 in Y direction. So we have 25 by 15, as you can see. And in here also again we have 0 at X and 15 at Y direction. So as we can see, this is the geometry of our slope. You can see the Y coordinate is 15 in here, and in here it is 35. So it means this slope is 20 meters high. if rigid safety factor is equal 1.52. So when we have a benches, the safety factor equal 1.5 to 0, so it means it is greater than 1.5 and it is acceptable according most of the guidelines. So in this lecture we show to you that these benches increase the factor of safety, and it can be easily performed in a PLAXIS 2D, which is based on finite element method. We can also check the failure surface in this case when we have a benches. So as you can see, this is a deformed shape for this slope with benches, and if I click on deformation, total displacement, we can see this is a critical failure surface of the slope. And again, we can check the shear strain also. As you can see, this is a failure surface for this slope. So this was for this lecture. I hope it was clear and useful. Thank you for watching. See you in the next tutorial.